Welcome to another knowledge sharing session. In the previous video, we explored how TBM face collapse happens. There we understood TBM face collapse is rarely caused by one single failure. It is usually a chain reaction. Here we will discuss how to prevent face collapse. Small operational mistakes slowly building into a disaster. Preventing it is not only about TBM condition and performance. It is about tunnel engineers' involvement and discipline. Understand the ground before the ground defeats you. The tunnel face is not just soil, it is an unstable wall carrying enormous earth pressure. The moment excavation begins, the natural balance of the ground is disturbed. TBM operator must continuously replace the removed soil pressure with controlled support pressure. If pressure becomes too low, the face can collapse inward. If pressure becomes too high, the ground above may heave upward. The first rule of underground is very simple. The face must never lose balance. As we have discussed, the most important job inside an EPB TBM is maintaining stable face pressure. Experienced engineers never trust one sensor alone. Generally, EPB TBMs have 6 chamber sensors, top, middle, and bottom sensors. Compare the top sensor reading with the prescribed pressure. A number of times, the TBM face becomes unstable. Tunnel engineers must check condition of sensors, periodical calibration, and cleanliness around sensors. When you monitor closely, you will find that during tunneling operations, the pressure difference between top and bottom sensors increased around 0.02 to 0.03 bars. Always refer top sensor reading with reference to prescribed value. Everyone will agree that maintaining face pressure is extremely difficult in mixed face geology. One side may be cutting hard rock while the other cuts loose sand. This creates uneven excavation behavior. One zone remains stable while another starts flowing uncontrollably. That is where many collapses begin. The challenge becomes severe on certain conditions. Existence of soft soil with rock interface, appearance of permeable sand and gravel lenses, occurrence of sudden groundwater inflow, continuous changes in face permeability, non-uniform excavation resistance. Real objective is not merely maintaining pressure reading. The real objective is maintain uniform effective support at entire tunnel face. Because in mixed strata, rock portion transfers pressure differently. Soft soil absorbs pressure differently. Water-bearing zones dissipate pressure rapidly. Hence, a stable sensor reading may still mean unstable face support. Pre-arrangements. Geological investigation to be conducted to get the rock UCS variation, RQD, fracture zones, sand lenses, gravel pockets, water table, permeability, K value. This determines probe drilling ahead of face mandatory in case of fault zones, transition zones, high inflow zones. Always monitor water pressure, sudden loss zones, cavities. In certain areas, pressure escapes into ground instead of supporting face. On-site solution. Increase fines content, improve soil conditioning, use foam with polymer, reduce permeability, maintain plastic plug inside chamber. Uneven pressure distribution, rock portion little deformation, while soft ground compressors, on-site solution, reduce advance rate, maintain uniform excavation, avoid aggressive cutter head penetration, maintain chamber volume. I would like to recommend few best operational habits such as maintain stable advance rate, avoid frequent stopping, sudden acceleration, rapid penetration changes, recommendation, slow and steady excavation because pressure fluctuation is more dangerous than slightly low pressure. The screw conveyor is actually part of the pressure support system itself. The soil inside forms a controlled pressure plug. If the conveyor removes material too quickly, face pressure drops. If discharge becomes unstable, the entire support system becomes unstable. Remember, never chase advance speed. One common operational mistake, trying to increase daily advance by overspeeding the screw conveyor. Production pressure from management sometimes pushes operators to mine faster than the ground allows. But in underground, speed without balance is dangerous. Experienced operators must monitor screw torque trends, muck consistency, conveyor fill ratio, discharge continuity, because inconsistent muck flow often means pressure instability is already developing. Raw ground is unpredictable. That is why soil conditioning is critical. The goal is to create a soft, plastic, controllable material. Conditioning is not a fakest formula. Many failures happen because teams continue using the same foam dosage for changing geology. But soil behavior changes every few meters underground. Good TBM teams constantly adjust minus foam injection ratio FIR, foam expansion ratio FIR, bentonite concentration, water content conditioning points. Poor conditioning can cause cutter head clogging, pressure spikes, main screw conveyor choking, high torque, and eventually face instability. Water changes everything underground. Even stable soil can suddenly become unstable when groundwater pressure enters the face. Never ignore water ingress. Minor seepage is often the first warning. Many catastrophic inflows begin as small leaks. Experienced teams immediately investigate the following: flow rate increase, water pressure change, soil washout signs, slurry consistency changes, surface settlement. To prevent major inflow, TBM teams use probe drilling ahead of phase, pre-grouting, ground improvement, pressure balancing, controlled advance rates. Because once large inflow begins, control becomes extremely difficult. Modern TBMs are powerful, but safety still depends on human decisions. Many phase collapses are linked to operational mistakes in the control room. For example, ignoring abnormal data trends, poor shift handovers, delayed response to alarms, incorrect pressure settings, advancing through unknown geology too quickly, communication failure between departments. Shift handover is critical. Shift meeting covering ground condition changes, cutter head behavior, pressure instability, water ingress signs, abnormal vibrations. Because underground, missing one detail can trigger major consequences. We know that preventing phase collapse is achieved by hundreds of correct decisions every single shift. Before disaster occurs, nature always gives warnings first. Will you notice them? Two rules to follow. Tunnel engineers' involvement: maintain phase pressure, continuous surface monitoring, frequent geological verification, proper cutter inspection, controlled advance rates, real-time instrumentation analysis, emergency response drills, backup pressure systems, maintaining chamber conditioning, regular operator training. Hopefully you have learned from this video. Subscribe for more real underground tunneling content and related stories.